This is this is a video on factors, including divisibility rules, exponents, and prime factorization. First of all, some definitions. Divisibility. When you divide one integer by other integer with no remainder, then you say that that number is divisible by the other. So 6 is divisible by 3, since 6 divided by 3 is equal to 2. 7 isn't divisible by 3 because 7 divided by 3 is equal to 2 with a remainder of 1. So it's not divisible because it has a remainder. So next definition, even numbers. Even numbers are divisible by 2. They end in 0, 2, 4, 6, or 8. Odd numbers end in 1, 3, 5, 7, or 9, and they're not divisible by 2. Divisibility rules. These are rules to tell if one number is divisible by another without actually having to do the division. So, an integer is divisible by 2 if it's even. In other words, it ends in 0, 2, 4, 6, or 8. 3 if the sum of the digits is divisible by 3. So, for example, we have the number 342. We add up 3 plus 4 is 7, plus 2 is 9. 9 is divisible by 3, so the whole number 342 is divisible by 3. 4 if the last two digits are divisible by 4. So we have this long number here. The whole thing is divisible by 4 because the last two digits are divisible by 4. 5 if the last digit is 0 or 5. 6 if the integer is divisible by 2 and 3, so you have to go back to the 2 rule and the 3 rule. If both those are satisfied, then it's also divisible by 6. 7 we don't deal with, it's too complicated. 8 isn't that helpful. And then 9, if the sum of the digits is divisible by 9, same type of rule as for 3's. For example, 81, 8 plus 1 is equal to 9. 9 is divisible by 9, therefore the number 81 is divisible by 9. And then the last one is 10. A number is divisible by 10 if the last digit is 0. Factors. Definition of a factor. An integer a is a factor of another integer b if b divided by a leaves no remainder. That sounds sort of complicated, but what we mean is we can divide it evenly with no remainder. So 2 is a factor of 6, since 6 divided by 2 is equal to 3 with no remainder. 2 and 3 are factors of 6 since 2 times 3 is equal to 6. Other factors of 6 are 1 and 6 because 1 times 6 is equal to 6. At times you may be asked to list all the factors of a number. So for example, here we're listing all the factors of 36. This is how I do it. First of all, you know that there, except for 1, there will be at least 2 factors, the number and 1. So we have 1 times 36, so 1 and 36 are factors. Then 2. 2 times 18, that's 36, so 2 and 18 are factors. 3. 36 is divisible by 3, and 3 times 12 is equal to 36, so 3 and 12 are factors. 4 times 9 is 36, so 4 and 9 are factors. And 6 times 6 is 36, so 6 is a factor. We just write it down once. Exponents. Exponents show repeated multiplication. So for example, 4 to the third means 4 times 4 times 4. It's basically shorthand instead of having to write down 4 times 4 times 4. We call the 4 the base here. We call the 3 the exponent. We can do this with variables. So like x to the 5th means x times x times x times x times x. We can do it with units, and we've done this before. Centimeters times centimeters times centimeters is equal to centimeters cubed. For things to the power of 2, we often say they are squared. For things to the power of 3, we often say that they are cubed. And you can think about our studies with volume and area to figure out why that's so. We have to go back to our order of operations also. Remember, please excuse my dear Aunt Sally. We didn't emphasize it before, but the excuse means exponents, okay? And so the exponents are what we do second after whatever we do in parentheses. So down here we have simplify 6 times parentheses 4 plus 3 in parentheses to the second power. First we do the operation in parentheses. So we add 4 plus 7, we get 4 plus 3, we get 7. So our new simplified expression here is 6 times 7 squared. Next, we do the exponent. So we're going to do 7 to the second power, and we get 49. And then, so the final operation, we're going to have 6 times 49, and we get 294. 6 times 49, by the way, you can do in your head pretty easily. Think of the distributive property. Think of 6 times 50 minus 1. 6 times 50 is 300. 6 times 1 is 6. 300 minus 6 is 294. Prime and composite numbers. A prime number has exactly 2 factors, itself and 1. A composite number has more than 2 factors, and 0 and 1 are neither prime nor composite. 1 has only 1 factor, so it doesn't meet either definition. And 0 really has infinitely number of factors, and it's treated as a special case. It's neither prime nor composite. Prime factorization is expressing a number as the product of its prime factors. We usually do it using a factor tree. We write the final factors in increasing order from right to left, and we use exponents for repeated factors. So I'm going to get out of PowerPoint. I'm going to go here. I'm going to go to a drawing program. So I'm going to go to, I'm going to go to Paint here. So let me bring up Paint. And so let's say, for example, I want to do the prime factorization of 72. So here's 72. A factor tree works this way. I think of a multiplication fact relating to 72. So I could go 8 times 9 is 72. Okay. And then I finish this up for the 8. So I go 2 times 4, and then 2 times 2. Now down here I have all prime factors for 8. 9, math fact, is 3 times 3, a multiplication fact. At the ends of these little branches on the factor tree, I circle these, and these are all the prime factors of 72. So I go 2 times 2 times 2 times 3 times 3. By the way, if you did that, you'll go 2 times 2 is 4, times 2 is 8, 3 times 3 is 9, 8 times 9 is 72. So when you multiply the factors together, the prime factors together, you better get back to the original number. I could express my prime factorization that way, but it's usually more proper to go ahead and use exponents too. So I have 2 to the third times 3 squared. Okay? And so that's how we do the prime factorization of a number. And with that, I will go ahead and we will cut this video.